Hello guys, my name is Francesco Ganora, and in this new Mule video I'll show you an important technique, which is how to aggregate the results of multiple subsequent calls to the same service. Actually, this is the first of a series of two videos. I'll show you two different techniques to do this. Let's start with the first one, which probably is the most common one. The objective, as I said, is to aggregate the result of multiple calls to an external service. Let's consider a simple REST service, very simple. You can see here my HTTP client, Postman. Here I'm invoking a service on my local Mule instance. This service is called get cities with a single query parameters called country. I specify in a European country via this query parameter, and I get a JSON array as a result with a list of cities in that country. So for Spain, I get these cities. If I choose France, I get a list of French cities. So this is choose Italy, which is my country. I get more cities. So very simple. This is actually implemented by this trivial Mule flow using just an array of cities and a matrix of cities, two-dimensional array, and a groovy component. So very simple, just as a simulation of what would an external service be. So what we want to do is to invoke this service for multiple different countries. For each country we get a list of cities and then aggregate or merge the results of these calls. So this seems to be a simple thing, but you really have to think about how to do it. Let's show a first solution. In the next video I'll show a second solution. For the sake of being short, I already built the solutions, but we'll walk through that first statically and then in debug and see how the solution works. So this, as I said, is just the mock service. So what we invoke to get a list of cities by country. So in this first solution, which is called Splitter-Aggregator enrichment flow, we assume we get as an input payload via post HTTP post, we get a JSON array containing a list of countries. So what we can see here, we have we're calling the Splitter-Aggregator enrichment with a post operation, and we're passing in the body an array of two countries, France and Italy. What do we do then? We need to invoke we want to invoke this cities by country service, which is implemented by my enrichment client flow. Invoke it multiple times, once per country. So we receive a list of countries. It could be 2, it can be 5 countries. For each country, we must invoke the enrichment client service, and then we must somehow merge the results. So the first step after receiving the HTTP request is to translate the JSON array into an array list, into a Java object, which is more useful for our processing. Once we have this collection, with array list collection, we can follow this strategy, which is invoking the client service, the enrichment client, for each element of this collection. So we we can use a collection splitter step to split the execution into multiple threads. Each thread will process one element in the input collection of countries. So for each country, there will be a separate thread being spawned, and this separate thread will need to invoke the enrichment client via this HTTP requester. So how do we do that? Then our plan, of course, is then to merge the results via collection aggregator. So we exploit the combined functionality of the splitter and aggregator, which work via correlation principle. So they generate a correlation ID. The collection splitter generates a correlation ID, and the results of the different threads of executions are merged together into a single collection by the collection aggregator using the correlation ID, which is present in each payload. So this is a good idea, but there are some details to be considered. So the first detail is that when we invoke an outbound transport, for example, here we want to invoke the enrichment client by HTTP, our current inbound properties and outbound properties are wiped out and replaced by the output of this transport. So this is important to take into account, because the collection splitter will set a correlation ID and correlation sequence, but then these will be set in the outbound properties, and if I don't protect this data will be erased by the invocation of the outbound transport here, and therefore the collection aggregator won't be able to aggregate anything, although we did spawn different threads for each member of the input collection. So how do we solve this issue is to introduce a message enricher. So the message enricher will make a copy of the payload of the inbound payload, and then execute the contents, the step which is contained. In this case, is a processor chain, because a message enricher accepts a single processor. So to be able to combine more than one processor, I need to use a processor chain to have a sequence of steps. And what we do is to accept as a result of the processing within the message enricher, we'll have a payload, which will be the payload coming from the enrichment client, and this will be mapped outside the scope of the message enricher into these flow variables called cities for current country. What's important to know, to keep in mind, is the message enricher is a Mule scope. So it's a scope that's different from the main scope of the flow that contains the message enricher. So when we exit the scope, we have this assignment from the payload inside the scope and to the flow variables outside the scope. The flow variables remains outside the scope, and whereas the rest gets replaced by the next iteration. It's not really an iteration, it's the next thread that was generated by the collection splitter. So the end effect of this is that we can set the payload of the main flow from the flow variables, which receive the output of our enrichment client, so the list of cities by country for the current country, and that will be the payload, become the payload at this point, to be aggregated with the similar payload being generated by the other threads. So we'll have different threads, as we said, depending on the number of countries in the inbound array. After each thread is done, they synchronize here in the collection aggregator, and that will generate a collection of all the output payloads from each thread. So each output payload will be a collection, so we'll have a collection of collections. To be able to generate an output, we will need to flatten this collection of collections into a single collection, so a single array. So at the end of the flow, we have an object to JSON step where we also set the content type, the MIME type, to text JSON or application JSON. And then we use a data weave transformer, a trivial one, where we just use the flattened payload operator and therefore transform an array of arrays into a single JSON array. So let's see how it works. So it's already started. This project is already started. I already showed you how this client works. So well, let's invoke. Let's actually first we need to set a breakpoint here on this initial step, and let's send the request. So this request stops immediately. At this point we receive a request where the body of the HTTP request that contains this JSON array is received as a stream. We convert it into a Java array list. So we step, the payload becomes a Java array list. You can see the two elements in the array list, which are the two strings, France and Italy. Then the collection splitter is going to create two threads that will follow the execution path independently and asynchronously. So the first thread, whereas before the collection splitter we had an input payload, a collection of two countries, here as a result of the splitter we only have in the payload the first element of the collection, let's say France. So the element is a single string that goes into the message enricher scope. You can see in the outbound properties that the collection splitter has set a unique correlation ID for this group, which is the group of two countries, France and Italy. The size is 2 because there are two countries. And here in this first thread, which is being traced, the correlation sequence is 1. So we're processing the first country, which is France. So we go inside the processor chain, and here we have the outbound invocation of HTTP, invocation of an enrichment client, which will retrieve the list of countries for France. So let's do that. It invoked this enrichment client, which gets the HTTP response as a stream again. We convert the stream into an array list. This works because we know the contents of the HTTP response body is a JSON array, which can be converted cleanly to a Java array list. So we're via this JSON string to array list. So then, yeah, we even exited already from the message enricher. The message enricher assigned the payload, which came from the HTTP client to the variable cities for current country. So we see that this variable is the array list which was set here. So the payload coming from the HTTP response to the client, to the enrichment client, was transformed into an array list and is assigned externally to a variable, so it's preserved. When we come out, we see that these correlation identifiers are not touched. If we didn't have the message enricher, we would permanently lose this correlation information, so the solution would not work. We set the payload, so now from the variable, so now the payload becomes the set of the list of cities for the current country, which is still France. We get the collection aggregator. The aggregator records this information, and then the execution goes back to the other thread, which comes from element Italy of the initial input. So we repeat the same for Italy. We go into within the message enricher scope. We see when now we're going to execute the outbound HTTP request, if we look at the outbound variable, they temporarily disappear as a result of the execution of the outbound transport. But that's only temporary because that happens within the scope of the message enricher. The payload, as before, is a stream that contains the response with the cities for Italy. This is converted to an array list. Again, the array list is assigned to, as we said, to the flow var. So we get out of this scope again. We get the flow var cities for country that contains the list of the cities of Italy. This becomes the payload for this thread. And here the collection aggregator finds when also these threads come to the collection aggregator, because the size of the aggregation set is 2, then it realizes that it can all just aggregate the results because it's done. There were only 2 threads for France and Italy. And then we get as a payload a list of lists. You see, this is the outer list, which is a special type of list. The class is a kind of special class. But the members are 2 array lists, and one contains the list of countries for France, the other contains the list of countries for Italy. We do an object JSON, and that generates a JSON array of arrays. You can see it here. When I execute the last step, this is flattened by the transformer, and I get this nice result. So I get the flat list containing the cities of France and Italy. I can add Germany, let's add also Portugal and Spain. I execute again, and then I just let it run until the end. And then you can see I get a longer list with all the the cities from the different countries that I requested in my original request. So we have 5 countries and we have cities from these 5 countries. What you can see is that the list of the cities are not ordered in the same way as the countries, because I start with Lisbon and Porto, which are the cities of Portugal, then the cities of Germany, then the cities of Italy. So ordering is not preserved. So this is I would say the most common solution in Mule for this kind of issue, the problem of to aggregate results across multiple outbound calls. But the disadvantage is that I don't keep the ordering. In my next video, I will show a different solution where we can keep the ordering and have first in the list that's output. First the countries in France, then the countries in Italy, then the countries in Germany, and so forth. So I hope this demo has been clear, and I'll see you in the next video. Thank you all. Have a great day. Bye-bye.